Okay, I am going to share my screen, and what I'm going to do is in this is the first of the series of virtual labs for this course. So in this course, before we can even get to the analysis, the policy analysis of nominal data, I have to show you how to get through the web of DePaul into SPSS, and then once in SPSS, how to get to where we want to be. So use this recording. You don't feel like you have to take notes, because this recording, I'm going to show you step by step, literally with the SPSS tab bar right here. So it might be better, if those of you, because I know when you look down and you take notes on a computer, you might miss something. So it's your choice, but know that you will have this recording. Okay. All right, I'm going to get started. If I'm going to keep it, I'm in 4 screens. So I'm going to be looking at the room to make sure I haven't forgot someone who's entering late. We're going to be streaming from DePaul, the SPSS program, and then running from DePaul a data set called the General Social Survey, GSS. Okay, and then we're on Zoom. So this is like really pretty high tech, but I just want you to know that if I turn, it's because I'm doing something. All right, I'm going to share my screen and we're going to get started. Okay, so now you see my Google screen, correct? Everybody? Okay. By the way, I don't have you muted. So, at any time, I'm the kind of professor, at any time you want to ask a question, you ask, unmute yourself. Okay. Don't raise your hand, because I'm going to be having my eyes on SPSS and the data set. So you just pipe up like we were in a classroom. You pipe up, unmute yourself and say, hey, wait a minute. Okay. Because if you have the question, somebody else has the question. All right. So once you're in Google, okay, what we type to get over to SPSS, we have to get over to by the way, if I'm explaining at too rudimentary of a level, please let me know. If all of you already know, does anybody already know how to get to SPSS and how to run it? Okay, so maybe Bridget. Okay, Sarah. Let me see who else. So I know. Anybody else? Okay, so there's 2. All right. So I'm going to be kind of rudimentary, Bridget and Sarah, because most of the students don't have it. Okay. And reinforcement's always good. But if you want to pipe up something like to contribute as a student, please do. All right. So I'm going to type in here. You can see depaul.aportal.com and then hit return. And this is a big program. So it's not going to be instantaneous when we get in there, and it's a big data set. We're using the real. I downloaded the 2018, the most recent general social survey that I could find. So it's going to be a large data set. So here's what you get on your screen. I hit login. We're going into the virtual lab environment. You can see up here in the right hand corner. I have an i9 processors. I have one of the top processors in my computer. So this is taxing me. Okay. You can see it's telling me I'm working. Okay. So you just wait. It's not as instantaneous as if you had it on your hard drive. Okay, so here it is. Here's what it looks like. And this is Porto. This is DePaul's virtual lab that they've set up. Next year, they're changing this. So what I'm teaching you right now, next year, they've abandoned Porto, and they're going to be in the fall, in the next academic year, putting in a new platform. Okay. So, but for now, this is what we have. And we hit launch. I'm actually streaming into DePaul's platform right now. That's what's happening right now. Okay, so this is what my desktop looks like, and yours will look very similar. I pulled out the 2 icons because I've been working in SPSS, but the 2 icons are generally sitting over there, and I just want to call your attention. This is not the SPSS icon that you want. We want the one that says Statistics version 26, okay? Just so you know, there's 2 of them, but this is the one you have to go and search for on this desktop and pull up. This is the actual program. Okay, this is what it looks like when you open the program. So it's asking you right now, do you have a data set you want to use, or do you want to create a new data set? So if I hit, and it already put me there, the open another file, that's telling me, do you want to go get a file? And if I basically cancel out of here right now, I would set up a file. Okay, what I'd like to do right now is teach you how to set up a file, because most of you already have your data set in hand or very close to it. Okay, and I've moved you all into Excel, put in your data set into Excel. When you do that, you have to make sure no percentage signs, no dollar signs, no characters, all numbers. We're dealing with policy analysis, so we have to be in all numbers, okay, for this to work. So what I'm going to do first, before showing you nominal data, is I want to give you a review very quickly of how to set up your own data set in SPSS. Okay, so I'm here going to cancel out of here, or I'm going to go to, I should say, I'll go to new data set, and there it is. You could cancel out too, and it will take you here. All right, so this is just like Excel. This should be familiar. However, this is not a spreadsheet. SPSS is a statistical package. So you're used to having these tabs on the bottom all be new tabs with new spreadsheets. That is not the environment we are in here. We are in the statistical package for social science, SPSS. So we have a data view and we have a variable view. The data view is where we will enter in all of our numbers inside the spreadsheet. The variable view is where we will set up the title of our variables, its description, and any missing values that we may have. Okay, so we're going to, as well as there's some, spacing and number of digits past the decimal point, etc. There's some aesthetic stuff that you can set up here too. But I'm going to walk you through this real quickly. So I've asked each of you to have a dependent variable, and I'm going to pretend my dependent variable here is crime rates. Oops. All right, so say it's crime rates. This first name is truncated, so you can't enter in a lot of information. It's only going to let you enter, and you can't enter in a lot of characters. So you're going to have to truncate or create a pseudonym, a name for what your dependent variable is. And as you can see, as soon as I hit return and crime rate as my dependent variable, I think I'm going to put Y in here. See if it'll let me. Yeah. Oh, yeah. See, it won't take my parents. So I'm going to put crime rate, and then I'm going to put Y without anything. All right. It's asking me if it's numeric. When you click on this, all of your data needs to be numeric for us to do policy analysis, for us to do statistics on it. There are other things like dollars and dates, okay, and commas, and string means it's words, and we can't do statistics on words. So be careful that all of your data is numeric. Here it's telling me the width of my data is eight spaces and 3 decimals, and you can change that as you like. If you're using whole numbers, you want to get rid of the decimals. Okay.
Professor?
Yeah.
Professor, is it possible to expand the screen so that we
yes.
could thank you so much.
Is it small to you guys? See, it's kind of big, but it was small.
It looks great now. Thank you. Okay. It wasn't too small, but it looks good.
Thanks. The better, larger is better. Okay, here is the label. Now, this is where you type in all of the information about your variable crime. Okay, and this is not what we will analyze, but this is what will be the identifier, the tag, along with the short name title here. So you can type away in here. We're not going to do analysis in here. And this is where you should make sure you put everything in there about this variable, maybe its source, what it means, etc. Values is a really important column under this variable view tag. This is where you're going to put in any codes that you use. And some of you, if you remember from the assignment on your own data set, this is where you can put in binary codes. Most of the data we're going to be using for your research papers is interval. So you don't need to worry about values because it doesn't have a code. Interval data doesn't have a code. But this is where if you did have a code and say one of our variables was binary and say it was 0 for no crime, okay, we would type that all in here. Okay, you must hit add. If you exit right now, nothing is saved. Okay, so you would hit add, and if we say, let me go back, if we say 0 is no crime, and we hit add, and then 1 is crime, and we hit add, then we hit OK. If you don't hit OK, it won't save. And there it is. If you look at this, you can see our variables, if we had to code them, is 0 and 1. 0, no crime. 1 is crime. This is important because when you do your analysis, you need to know the codes and you need to know this particular name because it will print those out. SPSS will print those out with the data and the analysis. Missing is important, and we're going to do some work with missing data. So all of you that had some missing data, you may not have been a person that had any. I told you to put in -9. This is where you declare to the SPSS program, -9 is not a real value in my data set. It means it is missing. You might have data that is missing that is from a range. And so we're going to actually see that today. So it might be a range from -9 to 0 or 1 that is missing. Sometimes you'll see inapplicable as 0. Sometimes you'll see -9 as missing. Sometimes don't know or wouldn't answer, refuse to answer. I mean, we want to get those out of our data so that we can analyze the actual responses. Because as you know, in social science, we have a very high non-response, right? People don't answer all the questions, and sometimes they don't even answer, you know, one of the questions. And so it's really important that we identify to the computer where that is. Okay. And then the rest are just columns, you know, how large is the column? How do you align the data? This is the aesthetics. You should ignore measure. You've learned about nominal, ordinal, and scale means interval or ratio here. You don't need to put that in. And when you work with data sets, which we're going to in a minute, do not rely on this because students have gone in there and changed this, and it has no impact on the program, and it has no impact on the analysis we're going to do. It doesn't affect the program's analysis. And the same thing here. You do not need to bother with this role right now. And so let's do one more, and let's say, I don't know, education, and that would be Y. Let's say it's Y1. Okay, and as you go down, you'll see, I'm going to put a couple of these in, property tax, maybe. I'm a terrible typist, as you all will know. Part, I think, is I can't see it. All right, so we've put in some variable names. I'm going to go over to data view now. And now you can see by putting these in, it's put them into our columns. Okay. Now I want to ask you guys, remember the lecture. So what goes in the columns? What goes in the columns in a spreadsheet?
The independent and dependent variables and the control.
Yes, Ray. That was Ray, right?
Yeah.
Yeah. So in one word, variables, right? So your X1, X2, X3, your Y, and your control. These are all variables. Okay. What goes in the rows?
U of A's, or units of analysis.
Yes. So what goes in the rows in a spreadsheet is your sample. So let's say we were looking at, I'm going to add, oh no, I won't add here. Let's say the first thing we were looking at was crime rates. Say we were working with cities and we were looking, say, at Chicago. Okay. I'm sorry, Chicago would be in this first list, and say it's, I don't know what it is. Say it's 12%. Say we got a 12. Okay. So this row here would, row 1 is Chicago. Row 2 would be Baltimore, the next city. Row 3 would be Phoenix. All right. So each row as it goes across is an actual unit of analysis. By the way, you have to memorize this. This is for all data sets. Every program you use, every analysis you do, this is part of the math. What's often helpful is if you can put in you see what I'm doing here? Because I did not put in a unit of analysis. If you can put in your first column, your unit of analysis. I went back and inserted that. And here I'm going to put it as, let's say our first unit of analysis is 1, and we said, let's make that Chicago. I'm adding codes for these units of analysis. Hit add. Number 2 would be Baltimore. Okay. When we go back over here, now we have a unit of analysis. And when we type in 1, which we coded as Chicago, we can type in 1 here, and we can type in 2 here. There's a bit of a delay because of the streaming. Okay. All right. And you can see that unit of analysis, when we come back over here, for Chicago is 1 and Baltimore is 2. Okay. So those of you who have units of analysis, this affects you for states, cities, countries, whatever your unit of analysis is, you need to code it with numbers. It does not matter if B comes before C, etc. But you do have to give one and only one code to that state, that city, that county, that country, whatever your unit of analysis is. Okay. And you code it in here like this. Again, when we do the analysis, it will take that tag and you will be able to see that in the output. It's easier for you to manage this data set if you have the codes inside of the data set. Questions? Because each of you have to do this. Questions?
Is there a limit on the amount of units of analysis you can have? Like, is there like a cap?
No. And you know, I've worked with in SPSS with 40,000 rows.
Wow.
Yeah. This is the Cadillac for analysis. It can handle anything you throw at it. And you're going to see that in GSS, the GSS data set we're going to work with. It's huge. So all the national surveys are done this way. All the presidential election survey research. I mean, everything is put in here as a policy analysis. So you may be working for, say, a county, a large city, a state. They're going to have some sort of large program like this in the workplace. Again, the thing that you have to remember is columns are variables, rows are the units of analysis in a spreadsheet. Now I'm going to change that up here in a minute. I don't want you confused. In a spreadsheet. We are in a spreadsheet environment, correct? You all say yes, yes, yes. Because we're getting ready to go into a cross-tabulation environment with rows and columns. And that's totally different than what I'm doing here. This is just data management and data entry. This is setting up your data set correctly. Because remember, this is a matrix mathematically. So you have to set it up correctly. If you switch this matrix, the computer's going to still compute for you. It's going to be wrong. But it won't stop you. It will still do the analysis for you, and you will get wrong results because the matrix has to be like this. Rows are units of analysis, columns are the variables. And that is across every program you use to do policy analysis, okay? It's a standard. Okay. Are you questions on this? Because now I want to go in and do some analysis. Questions on setting up your data set? You guys got it? I'm absolutely, go ahead, Steph. Go ahead.
So for the variables, do you, I mean, because you wrote them out, but you didn't like write out like crime rate or whatever. Are you not allowed to have like spacing and stuff like that? It has to be all together.
Yeah, it limits you on spaces. So sometimes you'll see an underline. Okay. Used as a space. It limited me on parentheses. It limits you. I mean, a lot of the characters, like the percentage signs, the asterisks, I mean, they're not allowed. Okay. And the spaces are limited. They're truncated. So you can't write the whole thing. The place that you write the full detail is in this label. Okay, gotcha. Okay, yeah. Thank you. Okay, go ahead, Bridge.
I have a quick question. So for mine, my unit of analysis are schools in the state of Illinois, and there's over thousands of them. Is there a way to manually input unit of analysis as rows, or how would I go about doing that? Would I just have to manually?
No, and a great question. Okay, so now let me. Can I talk to you about Excel now? Or is everybody done with this part? Can I move forward? You guys good? Okay. So Bridge is asking now the next step. And the next step is you have your data sets in Excel, correct? And I made you put them in rows and columns, just like what is here. What you do not have to manually enter anything in terms of data entry because I made you set it up so that it was conforming to statistical analysis, policy analysis matrix, rows and columns. All you need to do now with your own data set is go into Excel, have this Aporto SPSS program open, and copy, cut, and paste into this program. Now, so you're not doing any data entry. Now, a single percentage sign lobbied somewhere in your data set will cause an error. Just one. So none of these other characters you got to have a clean data set. And I've been telling and the feedback of D12, get these characters out, get them out. No dollar signs, no percentages, nothing. Okay. All right. So you cut and paste them. What you will need to do though, before you cut and paste it is you will need to go ahead and set up the names of the variables and all of this information here that we just went over. You have to set that up first. Now, be careful, right? Here's the trick, right? You may have to make sure physically that when you put the data in, or you copy it from Excel, that you put it in alignment with what was in Excel that you've now set up in SPSS for your column titles, right? You can't monkey that around. You can't shuffle that, all right? But that is within 2 strokes, you've got all your data in. Okay. Easy, guys? Okay. Are there any questions? Because all of you are going to be doing this. You're just going to cut and paste the data from Excel after you've put together these titles and set up your variables, and then you're going to go into data view and paste it right in here. If there's a failure, it's because usually you have a character in there. Sometimes spaces too. Sometimes you don't realize it, but you have spaces are considered a character, not a mathematical digit. So you've got to if you've got some kind of stray spaces in there, you've got to get them out. You've got to have a clean set of numbers. Okay. Make sense? Okay. Talk to me orally because like I can't see all of you and I'm looking. Yes, guys? Okay. All right.
Yep.
Thank you. Thank you. All right. Can I move on now to nominal data analysis? This is important. Yeah. So I wanted to take time. This is important. I can?
Yeah.
Okay.
Yeah.
All right. You know, I want to go back, like I'm coming back in, if you will permit me, because that's how you will be coming in. Okay. So now you know how to come in when you want to start your own data set, but I would like to leave and come back as if you're coming in to run an analysis. Okay. All right. So you would launch. Oh, it pulled it back up because it remembered on the streaming. All right. I will go to file and I will go to open and I will go to data. And I have put together a variety of data sets. Here they are. They popped right up. This is the GSS from 1972 to 2012. This is the National Election Survey. But I have some data that I've imported into our virtual lab because it's very large. And this is the most recent GSS. I could not get my hands on the GSS 2020, but I did get it on the 2018. And so you click on it, it's opening, give it a minute. And here it is. Here it is. Now we're in the General Social Survey. You can look this up. It's actually, the center for it is the National Opinion Research Center, NORC. Right in downtown Chicago, behind, I think it's behind the Apple store, if I remember, on Michigan Avenue. Ray, you work there now. You want to say something about the National Opinion Research Center?
Yeah, I started working there in August. When I was in before this, I was in New York and when looking for jobs here in Chicago. I came across NORC and I've heard of the GSS, but I never really dug into it. So it was cool to kind of see my company was involved. So yeah, I work like in the education and child development team, doing helping the researchers with like grant management. So I don't have too much involvement in the GSS, but I'm excited to learn more about it today, actually.
Yeah, and so the National Opinion Research Center, NORC, came out of the University of Chicago with some professors who developed SPSS. And so they actually created this program. And then, I don't know, about 10 years ago, IBM purchased the SPSS portion of NORC. And so now they're separated, but NORC is very well known for doing social science research of all kinds. And you're about ready to see that here because they ask all kinds of questions. They're one of the premier sources of information we get as social scientists and policy analysts, okay? So this is really cool that, you know, we've got somebody in the class that is actually from NORC and is learning GSS here in the class to take back to the job. I thought that was a great connection. All right, so here we go. You guys hold on, here we go. If I go too fast, you stop me, okay? Or if something's not clear, because this builds. We are now still in a spreadsheet environment. So the columns are our variables. Remember I said they get truncated? Here you go. Okay, so how am I going to know what this variable is? I have to go over to variable view. Here is just like we set up the name. And again, these names are truncated. So the way that I find out what is this variable about is that label. And there you go. It tells you all the description about that variable. And basically, these are the questions that were asked on the surveys. Okay, this is primarily survey research. All right. Remember, we talked about values. Here's the codes that we talked about. Remember, I showed you how to code. GSS already has their codes in here. 0 was inapplicable. Yes, no was 1 and 2. Don't know was 8. And 9 was not available. So you can see a variety, and this changes with each variable, how they code these things. It can change with each variable. Okay. Then missing, remember I told you, here they wanted to get rid of the inapplicable, the don't know, okay? So the 0, 8, 9 is actually put in here and is considered missing because we don't want to do analysis on inapplicable and don't know, okay? All right. And then this, remember I told you this was kind of aesthetics. I want you to, again, I'm warning you again, do not rely on this measure. It gets changed, and you have to know what is nominal, ordinal, and interval / ratio / scale from the lecture. All right. Questions on that? Okay, so we're in a huge data set. Again, set up by rows and columns, and the rows are our units of analysis. We're going to now start doing analysis. Okay, and the way that you do that is we're going to first start with nominal data, and we build in the class. We go nominal, ordinal, interval. Okay, all of the students are building at the interval level a model of regression. So we're just starting the baby steps of looking at nominal data. None of you are actually going to do this for your presentations and your papers, but you need to understand the beginning steps of nominal analysis. What is the definition of a nominal variable from lecture, guys? What is it?
It's like gender. It's not really like a unit of measurement. It's something that's like race.
It's a unit of measurement. All of these are units of measurement, nominal, ordinal, interval. There are levels of measurement. Let me help. Is it rankable?
No.
Correct. Can I do mathematical manipulation on nominal data? Can I say woman times man divided by woman equals?
No.
No. So it's descriptive, and we have to code it. By definition, you have to give something a 0 and something a 1. If you're dealing with gender, it might be 0 is, female and 1 is male. It does not matter who comes first. It is not rankable by definition. Okay? If something starts looking rankable, we're in next week's ordinal. We have a different, when things become rankable, we have a different set of policy analysis tools we have to use. Okay? So keep in mind, nominal is just categories that are descriptive, that can't be ranked, that in themselves can't be mathematically manipulated, have to be coded. Okay? Do they tell the most or least amount of information to the analyst? Least. So here's the tough question. Here's the critical thinking question. If I have data that is nominal, can I convert it to interval data?
No.
Correct. Because you can't go up the chain, but you can go down the chain. So nominal data is at the very bottom of the level of information, level of measurement that we have. Then ordinal, then interval. So I can take interval data and convert it down, collapse it down, and recode it into ordinal. And I can take ordinal data and collapse it down to nominal, but I can't go in reverse. Okay? You guys understand? That's a tough concept. And that's in the lecture, but I want you to keep thinking about that. You're going to probably start understanding it as you work more with your own data. All right, so I kind of watch you around. Now we're going to do an analysis. Now, just so you know, I've got several examples, and this first example, I've already loaded into D2L in terms of the output and the interpretation, and that's exactly what we're going to do here. But I first have to show you how to do it. Okay, so we're going to take a look at death penalty. Okay, as our dependent variable. And remember in the lecture, the 5 steps, we can just click away in here and I can get anything to correlate with anything. You've got to have literature review. You've got to have a research question, a hypothesis, some understanding and some validity of what you're doing. And so I ask you to do those 5 steps, write the research question, write the hypothesis, And then you interpret your results and answer the research question, right? Okay, that's the framework of how we do analysis. So I'm going to have us do, for our dependent variable, death penalty, the view on the death penalty, whether you support it or not. Okay, because this is nominal. And for the X, we're going to look at race. Okay, and it just so happens GSS has a variety of variables that they ask about race. We need a nominal variable. This is a nominal analysis that we're doing. So both our X and Y have to be nominal. Okay. And so the X that we're going to look at regarding race literally just is Caucasians and blacks. So it's whites and blacks. By the way, I don't like any of this language, but this is the language that you're going to see. And we're going to do a control called sex. That's what they call it. And you have to know those titles so that you can find those variables. And we're going to look at just female and male. Again, a control variable that is nominal. So everything we're doing here is nominal this week. Okay. All right. So how do we do that? So first we would write a research question. What impacts your view on the death penalty? And one of the research hypotheses we can write is in comparing people, because these rows are people. These are actual responses from tens of thousands of people actually across the United States on the view regarding the death penalty. So the unit of analysis in each row is people. So we can say here in comparing people, comma, and we're going to look at race. Which race do you want to pick of the two? Who's more likely to support the death penalty, blacks or whites? Pick one.
White.
Based on, right, there's good literature. Based on the literature, it's probably whites. So we will say in comparing people, white people tend to support the death penalty. Okay. You could have said it another way. In comparing people, black people tend to support the death penalty. Okay. Based on our data, you can say this either way because we only have a binary code, white and black, for race. Okay. All right. So here's how we go. There's the research question. There's the hypothesis. Now, let's take a look at, I'd like to take a look at those variables and before I start actually analyzing them. So you can see this is alphabetical. You can scroll down to race. Let's take a look at race first. And sex will be down here as well. You can see there's hundreds of variables here, right? So this is a very rich data source. I'm going to actually move here. I'm going to reshare this because I want to move it to put it in front of me. Okay. You can still see it now. I just reshared. Everybody, yes? Okay. So you can see we've got a lot of variables here. The variable that we want to use is actually called race. Here it is. And notice I'm in the variable view. I'm not in the data view. So here's race. It's numeric. Like I told you, all of these have to remain numeric. Here is the actual title. It's called race. Let's take a peek at how it was coded. It was coded 0 for inapplicable, 1 for white, 2 for black, 3 for other. Okay. And so sometimes you might want to write that down. So we don't want to analyze inapplicable and we don't want to analyze other. I mean, that's just not a very useful category. So we're going to take a look at the differences between what whites and blacks think about race. Okay. So the next thing we do is take a look at what's missing. And you can see, good thing, they took out the inapplicable and they took out 3, which is other. So 0 and 3 will not show up in our analysis. That's what missing data does. It pulls it out of our data set. Okay. The next one I want to take a look at real quickly before I run this, just to get you familiar, is sex. again, I'm not titling these things. This is literally what the GSS has. I think we're a little more sophisticated at that, but this is what respondent sex. And you can see they coded 1 is male and 2 is female. Okay, so 1 is male and 2 is female. Okay. I would write that down because we're going to talk about that code. Write down that 1 is male and 2 is female. All right. For missing data, there was no missing data, right? Because there was no don't knows or I don't know or didn't answer. It was all 1 and 2. Okay. And then the dependent variable is up above for death penalty. It's actually titled CAPON. In other words, capital punishment is what they were titling it. Here it is right here. And you can see the title of it is fear or oppose the death penalty for murder. They have favor and oppose. That's what we're going to analyze. And again, inapplicable, 8 is don't know, 9 is not available. So we want to make sure that those values are considered missing and not part of our data that we're going to analyze. And sure enough, they're coded. All right, back to the data view. Everybody good? Tell me, because I can explain it some more if you need it. Okay, speak up because I can only see so many on the screen. So use your audio to talk to me. Okay.
Yeah.
Everything's good? Oh, you have 2 people in the waiting room. Okay. Okay. Hang on a minute. Okay. Here comes Denise. Denise? I don't know if she's in there. Okay. All right. So I'm back in the data view. Here, we are now going to do some analysis, and you can see this is the tabs up here inside of SPSS. There's a variety of things you can do, just like in Excel. You can transform, you can search, you can sort, you can replace, all of those functions that you did in Excel. Many of them are here, but we are now going to analyze. And so we hit analyze, and we are going to start with nominal data. And so what we can do for nominal data is cross tabs, cross tabulations. And so it's under descriptives, and then it's under cross tabs. I'm going to leave this for a second. I want the video to record this. Okay, so that's the path into analysis for nominal data. This is the same place we will go for ordinal data as well. Okay, guys? Okay, so you hit cross tabs. Now, what is here? This is all of the values. Remember, we had those value labels with all the descriptions, and I find this unwieldy to work with. Okay, so what I do, but this is your choice, is I click on my right mouse button and I say, instead, I want you to sort by display variable names, and I also like it alphabetical. And so now we've got those truncated titles to work with. And so this is a little bit easier, I think, to work with, but it's up to you what you want. All right. Now, I've already taught you that in the spreadsheet, which is over here of our data, columns are variables and rows are units of analysis, correct? I have now moved you into a crosstab. Crosstabs have columns and rows. It is not the columns and rows of your data. It is the columns and rows of the crosstab, and it is the columns and rows of the analysis. Yes, everyone? I want to punctuate this point. Yes? This?
Yes.
Okay. Okay. Because this is a big point. Okay. So when we are in a crosstab, the rows are your dependent variable. Again, when we are in a crosstab, You've got to memorize this and do not confuse these things. Okay. When we are in a cross tab, the rows are the dependent variable. In a cross tab, the column is the X, the independent variable. When we are in a cross tab, I'll say this 100 times and somebody will still, it's really important you get this. Otherwise you can't read your analysis and you set this up wrong. Okay, if you set this up wrong, the program SPSS will still calculate it for you and it will be wrong because you designed it wrong. Okay, it won't stop you. All right, so our dependent variable, and let me show you a trick. When you're sitting over here, we're going to select, it was called CAP, CAPPUN, if you remember. And so if you're over here, you can type, and if you type fast enough, you can get 2-3 letters in, and it will take you directly to that variable title. Okay, so I'm going to put camp in the row because it's a dependent variable. It's the view on the death penalty, correct? And then I'm going to go back over here, and I know columns is my X, and my X here is race. Okay, here is race. I'm going to put that in the column. Remember, independent variables come first in time, space, logic. So usually gender and race are things that are X's. Okay. First, you're born a race. First, you're born a gender. First, you're born, you know, first you're a religion. Then you have a view on death penalty, if that can help you separate X and Y. It's logic, space, time, history. All right, so before I go any further, I now need to tell the computer what statistics do you want? And you must know that these are nominal. It will not tell you these are nominal. It's asking you, which statistics should I use? Well, as from the lecture, we learned chi-square. We're going to do chi-square on our nominal data. And we're going to go ahead and pick the phi. We'll talk a little bit about Kramer's phi, but it's the phi that we want. Okay. And then we will hit continue. Everybody see that? Okay. And then we will hit OK. We will come back to this screen for entering a control. The control of sex will be put into this box, but not right now. Hit OK. And here we go. Let me expand this. Here we go. This is what output looks like from SPSS. This cannot be cut and pasted and put into any kind of report or any kind of paper that you're doing. You must reformat this. And when you get to the results section of your paper, you're going to see how to do that. I have an assignment later in the class, but do not cut and paste this box and put it into anything. This is output. That's all it is. This is an output file. Okay. So now I want to teach you how to read the output file. Okay, what this is up here is these are all the codes inside of SPSS. In the old days, we would have to I would have to actually, when I was in graduate school, program these codes. Now it's just click, 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 right, with your user interface icons. On the left side is the actual output, and this is the output file. You can click on this, and if you want to, this is like an index, you can quickly move through the different boxes of output, but we're going to start at the beginning. So this is just an index that you can click on and you can delete it. You can delete any one of these, or you could, hop through them. All right. The first thing that comes out is helpful. And this is what you would use in your results section to describe your sample. Okay. So this box doesn't go anywhere. You have to read this box and you have to understand the information that comes out of this box. Okay. So here we go. 1,946 people answered all of the questions for X and Y. Okay. We asked 2,348 people. We asked 2,348 people, and only 82.9% responded to both questions. Okay, Our response rate, which you would report, is 82.9%. That's actually very, very high. If you know, social science surveys are 30% or less. And that number is getting tougher to keep elevated. So this is very high. This is very high. You don't see this number very often. Okay. How many people did not answer the survey? Or both questions. How many people did not answer X and Y? Based on that, tell me.
402.
Correct. And what percentage rate did we get not answering?
17.1.
Correct. Next one is the raw data of the crosstab. And you can see that the 1,946 was our total sample, and here it is. Okay, who responded to both X and Y. So now we're going to do, this is our matrix. The computer is going to do analysis for us on this matrix. I'm going to ask you now a series of questions. How many white people oppose the death penalty?
511.
Correct. How many total people oppose the death penalty in this sample?
699.
Correct. How many Black people favored the death penalty?
162.
Yeah, so you guys know how to get around this. You know how to read across tab raw data. Okay. All right, now comes the analysis. So in other words, when you see something like this and you're doing a description, you're in the results section, you need to describe all of this in sentences. You need to describe your response rate, how many people were asked, how many people did not respond, what that response rate was, how many people, failed to answer both questions. All right. And then you need to talk about how many people, when you are writing up reports and doing analysis, how many people were in each of these categories, as well as the totals, sentence by sentence, to describe that. Okay. All right. Now here comes the analysis, chi-square. From the lecture, what does chi-square tell us before I interpret this? What does chi-square tell us? It just, go ahead.
Say how the data compares to the. I don't remember.
That's all right. So it basically tells us if the two, because it's only for two variables, it basically tells us if the X and Y are related, if they're related or not. So in other words, are they independent or are they related? Doesn't tell us strength of that relationship, and it does not tell us the direction of that relationship. All right, strength, then direction. Let's talk about strength. This was all in the lecture, but now we're taking those theories from the lecture and applying them. Strength. And I said chi-square doesn't tell us strength or direction. Phi will tell us strength and direction. But let's talk about strength. Strength is negative or positive. And strength tells you which X value and which Y value are related and how strong they are. If I look at strength, 0.1, 0.2, 0.3, what did I tell you in lecture? What does that, how do you interpret 0.1, 0.2, 0.3 in strength? Weak, moderate, or strong?
I think those ones were
Weak.
Weak. Because it's like a percentage almost. Well, I think of it as like 10%, 20%.
Yeah, they're not a percentage, but whatever way you can remember them. 0.3, 0.4, 0.5 is considered moderate, and 0.3, 0.4, 0.5, and then when you get into the upper like 0.7, 0.8, 0.9, those are strong. 1.0 is perfect. 1.0 does not exist. Okay, that's the perfect. Direction is negative or positive. That is when X is increasing, is Y increasing? That's a positive direction. And when X increases and Y decreases, that's a negative or an inverse direction. Okay, all that comes out of your lecture. So let's start with chi-square, keeping all of that in mind. Chi-square only, and this is where you interpret it, here's where it sits, Pearson chi-square. We're going to learn Pearson's later, but we're working with the Pearson chi-square there. There is the value. So you will report 58.707 as chi-square equals 58.707. And then you will also interpret what's called the asymptotic significance. Now, this is for the big money. Why is it called asymptotic? What does the chi-square distribution look like? Remember lecture? What does the chi-square distribution look like graphically? It changes, right? It changes with the degrees of freedom. So your sample size. So that is not a static distribution. And so we have to use this asymptotic, okay? It's not a normal distribution. All right, so we're going to record chi-square equals 58.7, and we're going to record the significance, the asymptotic significance. Who remembers how do I interpret significance? This is right out of the lecture.
It's 0.05
or less.
or less.
Right. So anything, thank you, anything 0.05 or less, I conclude what?
It failed.
No, just the opposite.
Oh.
we want our results to be 0.05 or less, meaning there's a statistically significant relationship between X and Y. Okay. And we research, as social scientists, you research this because you're hoping that there is a statistically significant relationship between X and Y. Okay. So we want, by the way, this is universal. We want all of our statistics, all of anything we use as a test statistic to come out as 0.05 or less, because then we can conclude there's a statistically significant relationship between X and Y. Okay. You guys remember that from lecture? Yes, yes. Okay. So what do I conclude? Is there a statistically significant relationship between race and view on the death penalty? Yes or no?
Yes.
Yes.
Yeah.
Okay. So here's how you write the sentence. In comparing people, there is a statistically significant relationship between race and the death view on the death penalty. Perrin, chi-square equals 58.707, comma, and some people put in the DF. DF, you could say DF equals 1, that's optional. But you must put in the chi-square equals 58.707, and you must put in SIG, SIG period. Some people put the small letter P, both are fine. This is a probability actually, equals 0.000, close parent, period. Now, don't feel like you got to write this down because I have it already written down for you in the module, okay? But I want to introduce it to you right now. Okay? That's all you can say. You can just say, is there a statistical significant relationship? You can't tell direction, you can't tell strength. You want to, but you can't. What if I got 0.06? What do you conclude if I got a 0.06 over here?
There's no statistical relationship between the two.
Right. Absolutely right. Your test failed. So if my test fails, I don't go any farther. I don't interpret phi. Because if there's no relationship, there's no strength and there's no direction. SPSS and programs will still put out a fee for you because you clicked on it to put it out. Whether it's a statistical relationship or not, it will still produce fee because you clicked and told it to. Okay. You must know that if you get a greater than a 0.05 here, like 0.06, that you stop here and you conclude there is no statistical relationship between between race and view on the death penalty. Parent chi-square equals 58.707, comma sig sig period, which is sig equals 0.000, close parent period. Now we got a statistical significant relationship, so now we can go to phi. Phi is the coefficient that the metric that we use, the measurement we use, the coefficient we use to analyze the strength and direction for nominal data. All right. Phi, remember you just told me strength, 0.1, 0.2, 0.3 was weak, 0.4, 0.5, 0.6 is moderate, and 0.7, 0.8, 0.9 is strong, 1 is perfect. Okay. Now, the other thing I have to introduce is direction. We talked a little bit about it just a couple sentences ago. Phi can be negative or positive. If it is positive, as X increases, Y increases. If it is negative, which is an inverse direction, as X increases, Y decreases. Now, let me ask you the tough question. This is logic. This came, I think, in module 2 when we did hypothesis testing as well. Let me ask you this question. This is a tough question. If X increases and Y increases, and I told you that's positive, correct? A positive direction. What is it when X decreases and Y decreases? What is it?
Positive.
What is it?
Positive.
Correct. These are the same thing. I use this visual to help you remember. If X increases and Y decreases, that's an inverse. That's a negative coefficient. We're expecting a negative coefficient. What if Y decreases, X decreases, and Y increases? What's the direction we expect here for the coefficient?
Negative.
Correct. That's a logic problem. Correct. Correct. You guys get that? Because we're getting ready to, okay, good. We're getting ready to interpret phi. Phi is what? It's positive here. It doesn't put out a positive. It's positive. If it was negative, you'd see a negative sign, okay? So phi is positive, right? Is it statistically significant? Are X and Y related?
Yes.
Yes. The strength of that relationship is?
Weak.
Correct. We will do. Go ahead, Edward.
So that's basically saying, yes, there's a relationship between the two, but it's weak. So they're saying race does not have as much of a effect on their opinion on the death penalty as something else could.
Correct. Now, let's interpret direction. Saying it's positive or negative tells you nothing. That tells me nothing. It tells your reader nothing. Stay with me here. Do you remember when we were in the spreadsheet, I showed you the codes and I said, write down these codes. What got coded 0? What got coded 1? Remember that?
1 was male.
And 2 was female. And what was white and what was black in terms of race?
I think white was 1 and black was 2.
Correct. We have to interpret direction, and saying negative and positive means nothing. It's theoretical. It means nothing to the person reading the report. Which race? Which race? Is there a weak statistical significant relationship here? Which race? And which race we have to go back and take a look at. Now, let me tell you a shortcut. You can write down those variables, you can write down those codes like I made you do, but here's another shortcut. In SPSS, the variable that comes out first gets the lowest code. The variable that comes out next gets the next highest code. Same thing here when you read down the rows. The variable that comes out in the first row gets the lowest code. The variable that comes out in the next row gets the next highest code. Here's how I tell my students. In the United States of America, we read from left to right, low to high, start to finish. We read from left to right. In the United States of America, we read from top to bottom. We read lowest to highest. So try to remember when you're working in, because you're not gonna, you're as an analyst, you might not even get the data to look up. You're just gonna get this chart. You're gonna get this output, and you're gonna have to know how to read this output. Okay? They're not gonna, when you're on the job and you're working, you're not gonna just get the full GSS data set or the company or the public sector's data set. You're gonna get this output and say, okay, analyze this for me. Okay, so white got the lowest code, then black. Favor got the lowest code, then oppose. Okay, here we go. So we've got a positive phi, and that tells me nothing. We have to go back to the crosstab and interpret it. Which race, and I should be able to cover these up. Don't even try to use the numbers because these are different sizes by half. Okay, these are different sizes, almost by half. So using this coefficient and knowing these codes, don't look at these numbers because you can't do the math for chi-square in your head or for phi. Use the codes to answer my next question. Which race, based on a positive direction of phi, favors the death penalty? Which race, based on a positive direction for phi, favored the death penalty? Don't look at these numbers. They could be right, they could be wrong, because these are different sizes by a lot. So I asked which race. So here's what you should be thinking. I'm going to teach you how to think this, and then you're going to do it on your own. Favor got, say, 0. Oppose got 1, right? Lowest, highest. So I said favor. So X is going, or Y is going down. Let me use the right. Y is going down, right? It got the lowest code. Correct? You have to, do you understand what I'm saying, people? Students, please tell me.
Can you repeat it one more time?
That's what I want to hear. So this is a positive phi. We know in the United States of America, I'm goofy, but I'm helping you remember the jingle. In the United States of America, we read from left to right. We read from top to down. Left to right means lowest code, highest code. Top to bottom, lowest code, highest code. I asked you, who favored the death penalty? Here's the favored. What code did favor get?
0.
Right, it got the lowest, right? It could be 0, it could be 1, but it got the lowest code.
Okay.
Okay? So my little hand, my little thumb on, and this is the dependent variable, got the lowest.
Mm-hmm.
It's a positive correlation coefficient. Phi is positive. So what must, if I ask you what got the lowest code for Y, what must X be doing? What direction?
Going down as well.
Correct. And so it's doing this. So I said to you, you know phi, is positive. You know, I asked favor, which is the lowest, right? Code. For you to get to answer that question, you must know the direction of your codes. And it has to be going down, meaning it has to have gotten the lowest race code because it's this. X and Y are going the same direction because phi was positive.
Can you explain what phi would look like if X and Y weren't going the same direction?
It would be negative. There'd be a negative
Okay.
sign, Bridget. Like they don't put out a positive sign. It would have a negative sign right here.
Okay,
So,
Okay.
got it.
so technically to answer your question, it would be,
Who favors the death penalty based on this data and a positive phi?
it would be whites.
Correct.
So if the fee was negative, then we would say,
Wait. I don't want to go there yet.
okay.
I want to do one more thing, but you're on it, Edwin. I want to do one more thing. I want to ask it another way. Remember, there's two ways to get a positive,
Mhm.
right? It's this way and this way, right? I just taught you that. It's in the lecture too, remember? Okay, so let's try it out. Let's practice. What do blacks think about the death penalty? What are the black in this sample? What are the black view on the death penalty?
Oppose it.
Correct. Who said that?
Edwin.
Edwin, step the rest of the class through how you did that critical analysis, that interpretation. Step it through.
Well, we're basing it off of fee. I know it's a positive relationship, so I think that, as you explained, which has the higher code, so that's oppose.
No,
And
it's
then
black. I asked black. So start
Black.
there.
So okay, so oppose. Sorry, black. So they have a higher code, and it's a positive relationship, so they should also have the higher code, so it should be oppose.
You got it. You got it. Do not look at these numbers because the totals are different. This is almost by half. You can't calculate chi-square and phi in your head. Okay? So you have to go by the codes. You have to go by this, how the things were set up in the data set. You can either write those down or you can know my little jingles, left to right, top to bottom.
I have a quick question. So if the data set turned out that the black population actually favored it more, would that produce a negative phi?
You got it.
Okay.
Let me walk it through a little more slowly, okay? Okay, Bridget, I think it's important that everybody get that. That's a major concept. So now I'm ready to go to pretending we got a negative phi. Let's say that's negative. Okay?
Mhm.
Negative. It means the following, right? The first thing when you see a negative, you should be thinking this. X and Y, different directions for their codes.
Mhm.
Okay?
And it also depends on how the question is asked. Like when you corrected me,
Yep.
you said no, you're talking about black, so it's important to know.
Yes. I will.
what-
Yes, on everything, Edwin. You're right on top of it. So I can ask it in multiple ways. I can ask it from X and I can ask it from Y. Okay, so let's try. Negative. Let's go into the negative phi world, okay? In a negative phi world, what do whites think about their view on the death penalty in a negative phi? What
They
do
would oppose
whites
it?
think? Go ahead, Bridget.
They would oppose it?
Correct. Explain how you came to that critical analysis.
Because if we look at the codes, white is starting off with the lowest code of 1, and then favor and oppose. Oppose is the second code, so there's a mismatch between the two. So one's going up and one's going down. So it's a negative phi.
Correct. Let me ask it another way. In a negative fee, who favors the death penalty in a negative fee?
The blacks.
Right. Use your own words. So I can use words. I want you to use. How did you figure that out, Edwin?
Well, you asked, the question asks in a negative fee favors. So favors the, if we look at the codes, it's the lower of the two.
Mm-hmm.
So then I have to look for on the opposite, the higher of the two on the other column. So that would be the black because it's coded at the higher. And so.
You got it. All right. Before I move on, I want to do a control. Before I move on, are there questions? Let me test you then. Let me quiz you verbally. What does fee tell me? As an analyst, what does fee tell me?
The strength of the relationship.
And what else?
Direction.
Yep. And what else? It gives you a significance, right? There's the significance, right? What does chi-square tell me?
Just the significance.
Correct. And look how big this number is. That should be your first clue, right? It's not 0.1, 0.2, 0.3. It's not on a scale from -1 to 1. Now let me say a little word about Kramer's V. Kramer's V we don't use very often. Kramer's, but it comes out because it's a default that when I click fee, I get Kramer's V. Kramer's V is always positive. So it does not help us. If there was a negative direction here, we would not know it. So I'm never going to ask you Kramer's V. It's too limiting. Okay? It doesn't tell me enough. Fee tells me. Okay. Can I add a control now? You guys good? And by the way, that fundamental, what we just learned right now, carries through ordinal as well. It's the same thing in ordinal on how you interpret. No difference. Okay? So this was a really important concept. Is anybody lost before I add a control? I don't mind repeating things because it actually inculcates. Even students who already know, it gets firmer in their concepts and thinking.
So chi-square is just the significance.
Correct.
While phi is the significance and the direction.
And the strength.
And the strength. Okay.
Okay. Good. All right. Now we're going to add a control. Remember, sex was our control. Go back to analyze. Everything we do in terms of analysis is under analyze. Okay. And remember, it was under descriptive, and then remember it was under cross tabs. And it saves what you did last. Okay. So it's in here because I just ran this. So now I'm going to click over here and type very quickly sex. And I'm going to put it, remember I told you in this bottom box, that's where the controls go. And if you look back at statistics, it also saved everything we did. So I don't have to undo anything, but if you run something nominally and then you run something ordinally, you will have to change, okay? Because you can see here's the ordinal set of statistics, which we're going to do next week. All right, but it kept everything. So I just hit okay. And I hit okay. And up comes on the left-hand side of the index, the control run of this. And so we have the X and Y by themselves. And now we're going to go down and look at the control. So you can see up here is what we just did. Down here, as the index shows, is with the control. Okay. These numbers can be different. And I think in this case they are, aren't they? No, they're the same. These numbers can be different. Why can these numbers be different? Why? What did we just do with the control?
Added a different variable.
We added sex, yes. So somebody had to answer X and Y and a third variable, sex, for the control. If they skipped one of them, it's missing and it will get pulled out. But lucky for us, everybody that answered the first two variables also answered the control. So we've got our full 82.9% response rate. Usually it goes down. Okay, especially if any of the controls are socially biased or sensitive, like income. Okay, people don't like to answer income questions. All right, so you would interpret the same thing like we did before, you know, how many are in the, with the control and the X and the Y, you can answer all of that from up here. And now this is a really great way for me to show you what a control does, okay? So you learned a little bit about controls in the lecture, and controls are important because there's obviously other things that impact the relationship between X and Y besides just X. There's other things that describe Y and how it changes. And there's other things that impact X and Y, particularly in social science. In the natural sciences, you can control temperature. I've told many of you this already. You can control light, temperature, pH. We can't do that in social science. All we can do is check another variable and see if we take the variable, for instance, of sex as our control. We're interested in X and Y, correct? Okay, but now we want to look at sex, females and males. So we will take those black, say the black unit and the white unit for the X, the value of black and white, and we will separate out. So we will separate out the female and males out of each of those categories and see if the relationship still remains. Okay. If our control variable changes either in significance, the phi. If it changes in significance, the phi. That is the relationship between X and Y. If it changes in significance, the phi. If it changes the direction, if it changes the strength, any one of those, it means the control had an impact. Okay? If phi remains the same, if it remains the same, comparing the control of being male or female back with the X of being white or black. If it remains the same, it means there's no impact of the control. It's the same phi. Okay. Concept again. We will compare phi for the control values back to the phi that we did with the X and the Y. If there's any change in phi, that is significance, strength, or direction, when we compare that phi back to the X and Y phi that we just interpreted, if there's any change in significance, strength, or direction, the control had an impact. If it is the same, if phi comes out the same in significance, strength, and direction, there's no impact. Logical, guys? Okay, now let's put it into action. Here we go. All right, so here you can do the same thing here like we did in the last one. You can describe how many total and how many in each of the subcategories. That's easy enough to do. Notice, this crosstab reflects what I just told you in theory. We still have the X and we still have the Y, correct? See, X, white, black, Y, favor, oppose. But now we literally told, okay, guys, everybody who's male and white, go to that side of the room. Everybody who's female and white, go to that side of the room. And we run it again. This is what the computer's doing. We run the test between X and Y again. Here is the test just for males who are both white and black. Here are the results. Here is the test for females who are both white and black regarding how it relates to Y. So it's X and Y separating out just males, X and Y separating out just females. That's what a control does. We're checking to see if the relationship between X and Y still remains even within the subsets of the control values. Yes? Okay, good. So it will calculate a chi-square for us. We want to see if the chi-square changed its significance. Okay, if it changed its significance, there is a definite impact of the control. Okay, here is your asymptotic again. It's still significant, right? It's 0.05 or less. We don't read this. We don't read the chi-square value. It means nothing. Okay, it's not a coefficient. Remember, this is a double, it's not 0.1, 0.2, 0.3. Okay, it means nothing. You report it, but it's the significance that is important here. There is still a statistically significant relationship for males in terms of their race and view on the death penalty. Parent, chi-square equals 35.9, comma, sig equals 0.0000, close parent period. For females, statistically significant relationship, right? Can't read, can't report. You report chi-squared, can't read it. It's not a correlation coefficient. It's not 0.1, 0.2, 0.3. So there is a statistically significant relationship for females between race and view on the death penalty. Remember, chi-square only tells you if X and Y are significant. It does not tell you strength and direction. You have to go to phi for strength and direction. Okay, so right now, it looks like the control variable had no impact as far as we can see for X and Y. Okay, now here is the phi that we have to interpret. Now, we're going to get two phis because there's one for the females and one for the males, because remember, we separated them out in the room and we ran the X and Y's on each of them. Okay. So is there a statistical significance for males? Yes. Is there for females? Yeah. Yes, there is. Okay, so did significance change? No. Did strength change? This is 0.2, and you go back up to our phi from the full sample, it's 0.174. Is there a change?
Yes.
Yeah.
No.
No.
Why do I say?
Because it hasn't gone up a level.
You're on it because it's still weak.
Yeah.
I know what you meant, Edwin. It didn't go to moderate. It didn't go to
Mm.
medium or strong. You interpret strength. It's not a percentage. Remember, I stopped Ray from saying it was a percentage. You interpret it as weak, moderate, strong. Did it change categories? Did it change from weak?
No.
No, it's still weak. So there's no, in terms of significance, there's no change. And in terms of 0.2 compared to 0.174, there is no change. It's still weak. What if this was 0.4?
It would have changed to moderate.
Correct. Go ahead. What were you going to, I heard a question coming up.
Yeah. So just to kind of understand the overall, if we were just looking at data, someone would say, well, yeah, women oppose the death penalty more. Or they could even say
whoa, more than what? There's no more.
More than men.
No, that's wrong.
No.
No.
Well,
what are you basing that on, Edwin?
Well, what I'm trying to say is, if we were just to look at just numbers, we would be able to say, oh, well, white women are not as supportive of the death penalty because they have lesser numbers. But in reality, once we look at, no.
Nope.
Okay.
Nope. Let me finish walking you through, because I don't want to detangle what you're doing, but I want to correct it. Okay. So here's what we're doing. So I asked you, is there a difference in significance between the full phi? And notice what I'm saying to you. I am comparing the individual fees for the control back to the full fee. I am not comparing between men and women. I am comparing with this number, 0.174, which is the full sample, and this number. I am not comparing between men and women. I have to compare this fee to the full, it's a control. I have to compare this fee to the fee above, to the full sample. I compare this significance to the fee above. I compare this chi-square significance to the chi-square above, to the full sample. So a control is about looking back at the relationship between X and Y. Okay, did you change the relationship between X and Y in any way? Okay, here let's take males first. Significance is the same as the significance for this fee. Notice I am scrolling up and down to make that comparison. See this 0.201? I am not comparing it to this 0.150. No, 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 no. That's not the comparison. The comparison is this 0.201 back to the full sample, which is 0.174. Is 0.174 different than 0.201? No, it is weak. They are both weak. Okay, so we would conclude the following. There is no impact of the control of being male on the relationship between race and view on the death penalty. Parent, fee equals 0.201 comma sig period equals 0.000 close parent period. That's the sentence.
I have a quick question.
Mhm.
I actually have two.
Go ahead, Bridget.
What does it mean? What is the 0.00s in the significance column telling us?
If there's a statistically significant relationship between X and Y. In this case, if there's a statistically significant relationship for males between X and Y, for females between X and Y, because we physically pull the data apart based on the control and rerun the X and Y. That's why we have two fees.
Does the 0 mean there isn't a significant relationship? No,
just the opposite. We interpret significance as anything is significant that is 0.05 or less. So when significant is 0.0, I know it's anti-intuitive, right? You see 0, you think, no, there's nothing there. No. We are dealing with probabilities. And this is the probability of a type 1 alpha error. Okay. We are making 0 to no probability, we think, with a type 1 alpha error here. It's 0. So that means that there is a statistically significant relationship between race and view on the death penalty for men. Parent, fee equals 0.01 comma sig equals 0.000. It's antithetical. I know it's not intuitive. You have to memorize 0.05 or less means there's a statistical significant relationship. It's what you want.
Okay, perfect. Thank you. And then can you just one more time remind me the different ranks that like the 0.1, 0.2 equals weak, 0.3, 0.4, 0.5 equals moderate, 0.9, 0.8, 0.7, 0.8, 0.9 equals strong, and then 1.0 is perfect and doesn't exist?
Yeah, so 0.1, 0.2, 0.3 is weak, 0.4, 0.5, 0.6 is moderate, 0.7, 0.8, 0.9 is strong, 1.0 is perfect. These can be negative or positive.
Okay.
One should not happen, Bridget. One should not happen. If you get a 1, I'm going to ask for your data set.
Okay.
Actually, 0.7, 0.8, 0.9 doesn't happen. If you can get to like 0.4, you get in that moderate area, you can publish. Okay.
So just to clarify, when I was asking or trying to make an assumption, I was changing some of the variables because I wasn't accounting for the original one. I was trying to make the control the new
Yep.
Y or one of
The new X,
new-
you were making the
Yeah.
control the new X. I know, that's why I stopped you.
yeah. Okay. So that was a mistake I was making. So I need to just look at this as
Yes.
did the control have an effect? No.
Yep.
White females still correlate with white males in terms of opposition and favor.
The control had no impact. Gender has no impact. So the relationship, as you move back here, remember that relationship we talked about? White people do favor, black people do oppose. It does not matter if you're a female or a male. Gender
Okay.
had no impact. Sex had no impact as a variable.
Okay.
Okay.
And then sorry, go ahead.
No, you can keep going, Edwin. Keep going.
So but we can keep controlling for different other variables. So I can control for like income, education, and still keep comparing white and black. I just change the control, or can we have more than one? Only have one control.
Okay, with nominal data, remember when we did the analyze box, there's only one control that you can do because you're in a cross at a time.
Okay, but not at I was referring to not at a time, but in terms of our paper, we could control for like, oh, sex had no, but education did.
Right.
Okay.
But when we're at the lowest level of measurement, so there's only one control per crosstab that you can do, mathematically do. Okay, and you can see it here under analyze. Okay. Can I ask, what's our time like? How much more time do we have, guys? I think I went over. Did I go over?
I don't know what time it was supposed to go till, but it's 3:06.
Can I show you real quickly something?
Sure.
Okay, let me stop sharing. Let me show you what we just did so you can review it on your own with an answer key.
Can I ask a question about the control?
Sure.
So when we talk about the control variables, obviously what we just saw, like the control variable had no effect. Is it, I don't even know if this is like a question that even makes sense, but is it better to have a control variable that doesn't affect it? Or is it like, are you looking for a control variable that will affect the?
Oh, that's a really good question. So let me tell you this. So you're doing your research and you've written 3 hypotheses with 3 X's and a Y. And then you go and you get your control and you've done your literature review and you're really making these predictions with X and Y. You go out and you find a control and it has a tremendous impact on your X and Y. You now have discovered something you didn't know. It does disrupt your research because you now have to rethink this control and you have to go back and think about, okay, I am missing something because this control should have no impact. Your relationship between X and Y should remain regardless of the control. If it does not, it means you've missed something.
Okay.
And that's informative. That's not necessarily a negative. That's informative.
Okay.
Okay. In this class, if you find something, you're not going to go back and rewrite your research question hypotheses and do a whole, no. But in the real world, if you do find that a control, that's informative, that's important.
Okay.
By the way, that's publishable because you've discovered something. Okay. All right, real quickly, here is what we just did. Literally, all of the output, I went ahead and made it a PDF with the same numbers for you to practice. And this is in the module. And I also did the following for the module. I gave you those sentences and wrote them out for you. Okay. Because I didn't want you to write too much. I wanted you to think and listen. Okay, so let me get this here. Hang on. I'm going to reshare. Here it is. Oops. That's the same thing. Let me go here. Okay. Can you see it? Okay, so here's how I interpret it. And I was doing this. Remember I said, here's our research question. Here's how you report the results of the research hypothesis. And I was doing that for you verbally. Here it is in writing. Okay, so this is the full sample. Remember, I told you report the chi-square. Sometimes you can report degrees of freedom. That's a discretion. But you report this number and its significance. That should be an equal sign, by the way. And then here, same thing. You report your fee and you report its significance. You must always report significance with every test you run. Okay, the test alone is not enough. You have to report the significance value. Okay, and then here is some of the descriptions. Remember, we went through some of those descriptions about sample sizes and what does it mean. Here's some actual sentences for you. And then here's the control. And again, with the chi-square and the significance, both for males and females, and overall. Okay, and then again, here's the control information from the descriptives. Okay, so all of this is posted so you can practice.
Thank you.
Of course, of course. It's a lot. Now, we're laying a foundation today. We laid how to get into SPSS, how to put your data into SPSS, and how to run nominal and interpret it. Please, the next week, when we do ordinal, it's the same concepts. We're going to use different data. We're going to use different test statistics. We're going to use Kendall's, but it is the same approach in terms of significance, strength, direction, and control variable. It is all the same. Okay, we're just going to apply it to a different data set. Okay. Got it,
Thank
guys?
you.
Oh,
Thank you so much.
You are more than well. You are all, let me tell you, can I tell you something? Students that take me for this class get hired because they actually can put it on their resume that they are comfortable with SPSS and data analysis and setting up the data, managing the data, analyzing the data, and interpreting it. And that's what I want for each of you. I want you to come from zero background and go to get a job in it, because this is an employable skill, guys. I have students that have been employed and they knew nothing about statistics. We will never open up a calculator, but you will do analysis in this class and you will set up data sets and you will know how to do that. That's a very, very good skill, okay, to have. Okay. All right. Go have a good weekend. We're getting
Thank you.
snow.
Have a good weekend.
And thank you.
I hope it's been
Thank
enjoyable.
you.
I will linger if anybody has an individual question. I'll linger right now, but the rest of you go. And this will be compiled and put up there on the
Okay,
D12.
thank you.
Okay.
Great.
Thank
Thank
you.
you.
You're welcome. Anybody want to linger? I'm here for questions. Edwin, you're muted.
Sorry, I just wanted to stick around. I apologize for not communicating before, but I just couldn't get out of bed. But I need to make up some stuff. I know.
Okay.
I'm not sure what the policy.
Edward, let me stop this.
Okay.
Let me stop all this first, because this is going to be posted. Hang on a minute.